Welcome to myprojectbazaar.com. Let us discuss about local energy pattern for texture classification using self-adaptive quantization thresholds. Local energy pattern for texture classification using self-adaptive quantization thresholds. We propose an approach named the local energy pattern LEP, which can be considered as an extension of LPB. The main contribution is twofold, corresponding to the two fundamental problems of statistical structure representation. First is the generation of the local feature vector, the normalized local oriented energies which are obtained by rectifying the responses of the 2D Gaussian like second derivative filters are used to generate the local feature vectors. These local feature vectors are invariant to brightness, contrast and rotation to some extent. Second is the local feature vector quantization. We propose a n-array coding quantization scheme instead of the binary coding method in the LPB operator. The n-array coding method could preserve more structure information compared with the traditional binary coding. Moreover, it still keeps the advantage that it does not require the cost of performing the nearest neighbor computation like the codebook quantization scheme. During the n-array coding, we used histogram specification to train the quantization thresholds. This is the flow. The first block is load image and pre-processing. In load image, we initially load the input image. In pre-processing, the noise is removed. Noise is nothing but any undecided information that contaminates an image. These noises are removed by using some types of filters. Here we are using a median filter to remove the noises. Median filter is a non-linear digital filtering technique often used to remove the noises. Such noise reduction is a typical pre-processing step to remove noises to improve the results of later processing. Median filtering is very widely used in digital image processing because under certain conditions it preserves edges while removing noises. The second block is steerable filter. The descriptions for all local structures of an image are realized by using a set of oriented second derivatives of Gaussian-like filters. An important thing is that these steerable filters we used are XY separable, which helps to obtain the filter responses more efficiently. The second derivative of Gaussian filter is a bandpass one and is often used for image analysis. It can be rotated to an arbitrary orientation by linear combination of the basis filters, which has been used in motion, texture and orientation analysis. The third block is non-linearity and smoothing. Non-linearity is the operation of transforming negative amplitudes to the corresponding positive amplitudes. And smoothing. Smoothing is in order to obtain the more stable features to describe the local structure and be robust to noise. The energies are locally summed over a Gaussian weighted region with the corresponding pixel at the center to yield the local oriented energy. The next subblock is normalization. The normalization of local feature is one important step to reduce the effects of noise and image conditions. The next block is quantization. In order to transform the local feature vector to a code number, the elements of each local feature vector should be first quantized into n states. We need some quantization threshold to ensure the quantized local feature vectors are distinct and preserve enough information. The learning stage is to obtain some self-adaptive thresholds. The thresholds for n levels are set to so that 1 by n of the histogram area is within each bin between two adjacent thresholds. The thresholds are learned for each database and they may be quite different from one database to another. Experienced quantization thresholds can hardly fit all of the databases. The next block is LEP feature extraction. LEP feature extraction is subdivided into local energy pattern dominant and local energy pattern histogram bins. In local energy pattern dominant, the maximum of the local oriented energy in different orientation is relatively stable, whose orientation is considered as the dominant orientation. Specifically, every local structure has its own dominant orientation and the elements of the local feature vector are cyclically shifted according to the local dominant orientation. In local energy pattern histogram bins, It produces different output values, and some values correspond to the same local structure if we consider the local notation. The next block is SVM classification, support vector machine. In SVM, it maps the input vectors to a higher dimensional vector space where an optimal hyperplane is constructed. Among the many hyperplanes available, there is only one hyper that maximizes the distance between itself and the nearest data vectors of each category. These are the programming files. The main.m is a main file. We have to run only these files, and the remaining are the subfiles. I have to run the main.m file by right clicking on it and then press run file. A new guide window is appeared. Click on initially I load the test image enhancement push button to load the input image. Select the input image from the testing folder and then select any one of the image. I choose one first image and then select open. The input image is loaded. Next I apply the steerable filters to the input image by pressing this push button. This is the input image and it is a filtered image and it is a oriented filter. Before I saying that the description of the local structures of an image are realized by using a set of oriented second derivative of Gaussian like filters is performed in this filtering block. Smoothing is applied to the input image by pressing this push button in order to obtain more stable features to describe the local structure and be robust to noise. The energies are locally summed over a Gaussian weighted region with the corresponding pixel at the center to yield the local oriented energy. This is the smoothed output. Next, the normalization is applied to the image. The normalization of local feature is one important step to reduce the effects of noise and image conditions. This is the normalized output. In test image LEP feature extraction, we extract the feature values of the input image. The UE table shows the feature values of the input image. In train image LEP feature extraction, we extract the features of all the images in the dataset. The UE table shows the feature values of all the dataset images. These are the feature values of all the images in the database. In SVM classification, we map the feature values of the input images and the feature values of the overall dataset image and find the input image belongs to which domain. This output shows the input image recognize the aluminum foil. From this, I conclude that our local energy pattern for texture classification using self-adaptive quantization thresholds gives accurate results. Thank you.